Thanks very much. So next up to on more of the lighter part of the afternoon is to introduce Dan Vatca from Syneto. They're a Romanian-based ZFS company that he's going to do a quick presentation about. Oh, hold on, do you need to? His presentation is going to be about another bit of the market trends, which you may have heard of, more of a high-level overview, and how that integrates with ZFS. The hyper-converged market trend, which is kind of combining both compute, storage, and networking into either one single appliance or a single scalable appliance. So, once Dan's set up, he'll be doing a talk about how that's sort of relevant to ZFS and what those guys are doing to bring that to the market and to the community.
Thanks, Ryan. Hello, everybody. Just a quick, I need some time to just set this up so I can...
Solid. So how many people have heard of hyperconverged or are kind of acutely aware of hyperconverged as a trend? Yeah? Cool. So it looks like there's going to be it's going to be an interesting presentation with Dan and doing some education. Awesome.
All right. So, hello everybody. Really glad to be here to talk to you guys. I think you're a great bunch of people. So I'd like to start just by telling you a bit about ourselves, who we are, and what we're doing. So we're a company that has been doing mostly storage appliances. That's what we started out doing. We have our own version of a storage OS, which is actually based on Open Indiana in the beginning, and then we're trying to evolve that. But the idea of the storage OS is to allow us to build appliances which are fairly easy to use for our customers, which have different needs, and we always try to cater to those needs. What I'm going to talk to you about is our experiences in following this new market trend, which is the hyperconvergence. So first of all, this is a new hype, so everybody's talking about it, everybody wants it, and first of all, I want to ask you, which of you knows what hyperconverge means, or do you have an understanding of that, or is this something that just occurs to you? Okay, so judging by the looks, I think that this is not such a familiar term. So hyperconverged storage means that, well, at least that's what the market is trying to make it perceive, is how to get storage together with the CPU power and the networking and bundle it all together. So that's something that has a lot of advantages, at least from the customer perspective. And one of the advantages is that it's much easier to deploy. So you got building blocks which are made out of storage, networking, and compute, and then you get those building blocks and you build your infrastructure. So it's much more predictable when you're trying to add more compute and everything, and when you're trying to scale. And another important thing that our customers are interested in, having a single point of support. So sometimes they just need to talk to one company and they would be able to sort that out. But today's meeting is about ZFS, of course. So what I intended to discuss today is how does ZFS help those hyperconverged storage world? What's the power of ZFS, and what does ZFS do for these kinds of applications? And I'm trying to share to you some of our experiences and which are the power points of ZFS that make this solution appealing to customers, and how does ZFS improve that? So the main all right. So just okay. So the main point of using ZFS is its flexibility. So first, it's very easy to implement a lot of pool management solutions like snapshotting, moving pieces around. But the main point of ZFS is data integrity. So I think that this is the single most important thing that has brought up to use ZFS, or ZFS has brought to the hyperconvergence. So when you write data with ZFS, it's there. I mean, this is the most important thing, that you don't have problems with data corruption and so on. All right, so okay, just one quick question. I don't know what's wrong with this presentation, I think. Yeah. Okay, so we've got two types of hyperconvergence. So these two types of hyperconvergence are usually looked at from the perspective of who's running on the metal. So in one type of hyperconvergence, the metal or the operating system that gets installed on the hardware is Syneto Storage OS, for example, or Illumos, and on top of that, we go and virtualize and run virtual machines. Our implementation currently uses KVM in Illumos, and we use that to manage one VM per data set, and that allows us a great deal of flexibility in deployment. So we have everything contained. We can move data around. We can backup. We can snapshot. We can replicate. So that's why we can build an online shop, for example. You can get a lot of templates for virtual machines, and then you can go from there and deploy in different scenarios. And we can use ZFS send receive to replicate and deploy those in production. But we also benefit from all the inline compression for example, each VM by using LZ4 in terms of hyperconvergence. We've seen that that compression helps a lot. I mean, in production we see not uncommon compress ratios of like 2 to 3 times compression ratios. So that's quite important for having a right level of optimization of the space and so on. And then again, deploying large numbers of equally configured machines by using clones, we can deploy farms that can easily scale. And that's by using LZ4. That's very interesting, and by using the send receive to replicate machines to remote offices. So this is the first kind of hyperconvergent solutions that we have. Do you have any questions on that one?
You mentioned dedupe. What kind of dedupe ratios are you getting on top of, like, you're already using compression and it sounds like snapshots and clones? How much additional benefit do you get from dedupe?
Okay, so we don't use dedupe all over the place. I mean, we've been deploying in production some dedupe workloads, and we've been working with trying to understand the performance characteristics and how's that impacting. And we've been using SASO's port of SASO's implementation, a port of SASO's implementation of the idon R, because we wanted to put that through paces to understand how that really how that really performs in production, and that's yeah, yeah. So the thing is that it really does help, and I think that it's. I'm very happy because I saw that you've been working on bringing that into the next upstream release. That would be really awesome, because we've been, of course, as you said, integration is always hard. So putting the pieces together and getting that upstream, that's really interesting.
It's 10% actual coding and 90% evangelism.
Yeah.
Yeah, I actually finished Sasha's work and have that ready to integrate into Lumos. So that'll probably go up for review tomorrow.
Yeah, that's
if I
cool.
have time.
Yeah, that's cool. All right.
But my question was more about like what kind of dedupe ratios are you seeing?
Ratios. Well, we're using the data sets that we have are actually file systems. So that means that we need to tune down the record size, because on top of that we're having the KVM their format for disks. So if we leave it the default, the 124, the dedupe ratios are like 1.01, and that's totally unusable. It doesn't make any sense. Of course, you don't have problems with memory in that case, but you're not using it for anything. And but when you tune that down, you can get up to between 1.5 and 2.5 dedupe ratios, but you'd have to be very attentive about how much memory you have, because if you have you cannot tune down the block size to 4K, where you'd get a very high dedupe ratio, but you don't have enough memory. So that's of course, in production you don't go that low. Okay.
Cool. Yeah, thanks.
All right. So nothing comes free. All right, so this is our second type of implementation that we're using. And this is actually a virtual appliance running together with VMware. So we're running that on as an VSA, which is a virtual storage appliance. And on the Metal, now we're running ESXi, which is the VMware's hypervisor. And storage OS is running in a virtual machine. And for performance reasons, and because ZFS is the best way to manage drives, because of the volume manager, of the zpool, and all the management that ZFS does better than other file systems, we are passing through the HBA. So the HBA gets passed through to the storage OS that runs as a VM. Of course, we have to lock down all the memory that it gets. So, our virtual appliance will manage everything. We'll manage ARC, we'll manage ZIL, and we'll manage the drives. And then it will expose that space through NFS, through all the VMs. And the sharing of the NFS is done through a separate networking, which is in memory. So basically, you're just having like a very high bandwidth network connection to all the from the storage OS to the ESXi, which will then connect that to the virtual machines. And of course, you can add other nodes that can take advantage of the same one, and you can go on and scale it. You can scale that by adding more nodes, which will also have their own storage, and they have their own virtual machines. So you can just go on and replicate that. So yeah, the best idea is to leave the storage to ZFS, which is the best way to manage storage. Here in our appliances, we also take advantage of our developed VMware integration. So each time we're taking snapshots, we also talk to the infrastructure below, which means to the SXI, and we synchronize our snapshot schedules and replications to synchronize those with the snapshots of VMware, so that you get memory consistent snapshots and snapshots that are integrated through the VMware tools to the applications that run inside. So that's that allows us to actually take advantage of both the ZFS snapshots and the replications, and of the other features that we get from the hypervisor itself, meaning consistent snapshots with memory consistent snapshots. Another thing that we're seeing very frequently in production is very high hit ratios on the ARC with normal workload. So between 95 and 98% ARC hit ratios are quite common.
Just a question, you said that you have storage co-located with the compute essentially. And you say you're integrated with VMware Snaps. Are you able to, for example, use that to migrate VMs between boxes? That'd be kind of interesting. To take a snapshot, then ZFSN receive on another pod and
migrate it. Well, this is usually for disaster. What we're using now is not using that to migrate.
Sure. Well, okay.
It's just to have a disaster recovery where you're up and running with the whole infrastructure.
Okay, so you basically can have a VMware compute cloud with shared nothing infrastructure and still be able to disaster recover machines, even if your storage goes down. Or
yeah, that's the idea, so that you have it everything as it was powered up at the.
Neat.
But you need storage motion to actually.
Yeah, to do the. Yeah.
It was me. Yeah, it was. But you need storage motion, vMotion.
Yeah, if you want to automate everything, you'd need storage vMotion. Yeah, that's not.
Yeah.
You cannot do that right now with storage vMotion, and
because you don't have any shared storage.
Yes, it's not actually shared. No. So even if we would, I don't know, make a replication which is continuous,
it still doesn't work.
It won't work. Yeah, it needs to be the same one. It needs to be shared for. Another feature that we use from ZFS is actually the ZFS Snapdir, which is a fast way to recover to recover individual files from a virtual machine. So sometimes we just need to take a quick look in the past and see what was there. So we take one virtual machine, we isolate it, and then we see, okay, so this is what I wanted, this is not what I wanted. All right, so what's next? So what would really make ZFS even much better for hyper-converged storage appliances? And that's one of the best things to develop and to work on, to improve, is a better DDoP algorithm. So continuing to fine-tune that, to find newer solutions, to for example, NVMe is such a nice solution. It has very much appeal because it's very low latency. It has high capacities. So offloading the DDT table to an NVMe, that would be a great improvement. Another improvement that we would like to see is making ZFS cluster aware by implementing ZFS multi-modifier protection, and to make it safe and not force the above implementation to rely on SCSI reservations or other kinds of solutions that are actually coming from the outside in, instead of having ZFS just manage that problem of having a pool destroyed, auto-destroy by being imported on two nodes. Yeah, because it's so easy to just run import minus F.
Oh, we've all been there.
Yeah. Other features that we're trying to see implemented in ZFS, it's dataset quality of service, per dataset quality of service. Giant has been doing a very nice work on to implementing that for zones, but that I think it could be a very nice benefit to the ZFS in general, having a per dataset throttle, for example, making sure that certain database applications don't eat up all the I/O that's available, so they don't starve the other applications that they're trying to run on. And one more thing, I remember that we, well, this has been discussed before about distributed file system on top of ZFS. I don't know what's your opinion on that. I'm trying to reiterate a theme that we've been finding in production, and that's finding a solution to finding a way to marry those two concepts. Like, how do we manage to scale out ZFS? That's something that's really nice, because we really want the power and what's ZFS providing today, which is reliability and its flexibility, and make that distributed. I don't know, maybe something that's at the same layer in the stack as the ZVols, the volume emulator, and something like, I don't know, making Gluster FS being at the same level as the POSIX, ZPL, and the volume emulator.
Yeah, I think that's already been done with Lustre, at least on Linux. I know Intel and some other folks are actually supporting Lustre on ZFS on Linux, with where it's like basically implemented at the same layer as the ZPL and ZVol.
Yeah, something like that. But wouldn't that be a yeah? And you started a port on
native Linux.
Okay, so but my idea was, does it make sense to have that ported at the ZFS, meaning that all distributions could get all, for example.
So the way they did it is, well, Lustre is Linux specific, and they're just using ZFS as a sort of reliability backend. So they're only each individual node in the Lustre cluster is its own ZFS island, and Lustre is sort of the real organizer of data. So you're not gonna get, well, certainly not ZFS snapshots and send receive and stuff like that. No, it's all Lustre specific, and I mean it's tailored to their needs. I mean they're running a 700 node cluster.
Yeah, it's true. But I was thinking about something that could be generally used. I don't know how practical that would be, but yeah, that's something I really look forward to exploring the opportunities on that. So that's it. Thank you guys for. If you have other questions, of course, I'm here, and we have all the.
So why are you after the distributed FS? You want something that's bigger, something that's better HA, something
Well,
that's more clients, which.
No, we're looking after scaling linearly. So because we're not after scaling just in terms of space, but scaling performance along with that. So that's the holy grail in the end. Because right now ZFS, it's very scalable in the same system, like adding. Yeah, let's
scale up.
We just scale up. What we're trying to understand is how can we scale out, and that's the reason, that adding more processing power.
Okay, so any other questions for Dan? No? Okay, cool. Thanks, Dan.
Thanks.